Hi everyone. In today's lesson from Unit 1.2, we will be taking a look at a transformation that is called a dilation. A dilation is a transformation that produces an image that is the same shape as the original, but is a different size. In other words, this is definitely not an isometry. A dilation stretches or shrinks the original figure. So we either want to enlarge the figure or we want to make it smaller. The description of a dilation includes the scale factor, or ratio, and the center of dilation. The center of dilation is a fixed point in the plane about which all points expand or contract. So let's take a look at our first two examples. In example 1, it says we are to perform a dilation with a scale factor of 2. That's what this little 2 right here means. And we're supposed to take every point xy and map it to a new point by doing 2x and 2y. So 2 times the x coordinate and 2 times the y coordinate. So this means that our new point, P prime, will be twice as far from the center of dilation than the original point P was. So again, when you perform a dilation, you have to know the center of the dilation. In this case, we're working with the origin, so that point is marked point O. And when we do the dilation from O to P, I would say that I would count up 2 and to the right 1. So the dilation is telling us to use a scale factor of 2, so we want to double that distance between O and P. So if I do this, go up 2 to the right 1, and then I want to repeat it a second time, up 2 and to the right 1. So P prime is at the point 2, 4. So our original point, P, was at 1, 2. And according to this dilation, it maps to the point P prime at 2, 4. Now, when your dilation is centered at the origin, and you know your scale factor, you can just take your point, my point P, and you can multiply each coordinate by the scale factor to find the new point P prime. In our second example, it says that the triangle A prime, B prime, C prime is the image of triangle ABC under a dilation about O, the origin, with a scale factor of 1/2. It didn't come out so well when it was printed, so this should be a scale factor, or in other words, a K value of 1/2. K is what we use to represent the scale factor. So in this case, it's a reduction. We're shrinking the triangle, making it half the size of the original. So when you go to do that, notice that going from the origin to point A, we would be going up 6 units and to the right 2. So we want to cut that distance in half, so you go up 3 and to the right 1 to find A prime. So A prime is at the point with coordinates 1, 3. We'll do that for the point B, and when we go to B, we will go up 2, or you go to the right 4 and up 2, and then we want to cut that distance in half, so go to the right 2 and up 1. So B prime has coordinates 2, 1. And finally for point C, you go to the right 6 and up 4, so to cut that distance in half, so we go to the right 3 and up 2. Okay. So again, in this case, because the dilation is centered at the origin, we can just take the scale factor of 1/2 and multiply each x and y value by 1/2 to find the coordinates of the new point. Okay, in example 4, it says draw the dilation of the image of pentagon ABCDE with a center of dilation at the origin and a scale factor of 1/3. So this would be a dilation, scale factor of 1/3. Okay, and our hint again says we can multiply by 1/3, and that's the same as dividing by 3. So if we wanted to do this just algebraically, because it's centered at the origin, you can multiply every x and y value by 1/3, or again, you could divide each of them by 3 in order to create your new points. So keep in mind that the center of dilation is the origin, and I see that that's where point A is. Well, A prime would still be 0, 0, because 1/3 of 0 is 0, so it makes sense that A and A prime would be the same point. All right, for point B, I see that it's at the point 3, 3. So if I want to go 1/3 the distance, divide each of those by 3, and that means that B prime is going to be at the point 1, 1. Because 3 divided by 3 is 1. For the point C, I see that it is at the point 6, 3. See if I can write that a little bit neater. And so if I want to go 1/3 the distance from the origin to that point, I have to multiply each of those by 1/3, or again divide them by 3. 6 divided by 3 is 2. 3 divided by 3 is 1, so C prime is at this point 2, 1. There's my pentagon so far. For point D, it has coordinates 6, -3, so divide each of those by 3, and we get the point 2, -1. And there's D prime. And finally, for point E, it has coordinates 3, -3. If we divide each of those by 3, we get 1, -1. And that finishes off our pentagon. So pentagon A prime, B prime, C prime, D prime, E prime is 1/3, okay, the distance from the origin to each of those new points. All right, in our last example, we are moving the center of dilation from the origin to a different point. And it says that we are to draw the dilation of the image of rectangle EFGH with the center of dilation at point E. Okay, so all measurement is going to be based on the distance to point E. We have a scale factor of 1/2. Okay, so we want to cut these distances in half. So our hint says that point E and its image are the same. So E and E prime are both at -2, -2. Okay. To draw the dilation, it is important to observe the distance from E to the other points in the figure. Okay, in other words, since the distance from point E to point F is 6 units, when we perform the dilation, the distance from E to F prime has to be half, because our scale factor is half of that. So the distance from E to F prime has to be 3 units. So if I measure from E up 3 units, then I get F prime. So F prime has to have coordinates -2, +1. Okay. So if we go from E to H next, all right, we're going to go to the bottom here. This distance is 4 units long. Okay, and according to our dilation, we want to go half that distance. So H prime will be right here at the coordinates 0, -2. Make sure I put those in the right spot. Okay, finally, that point G, to get there from point E, we would go up 6 units, and then to the right 4. We want to cut that distance in half, so that's this distance right here if I mark it along the diagonal. So cutting that distance in half, we would go up 3, and then to the right 2. So G prime would be at point 0, +1. Okay, that's it for our final example. I'll finish drawing that in. All right, good luck on the check your understanding, and as always, let your teacher know if you have any questions.